Yes. So Kevin, you will get access to the recordings on the student portal, which I'll show you later, which you all should have gotten an email for. The student portal will have the recordings link listed there. I actually also upload the recordings to a dedicated YouTube link that's private, unlisted, just for you all. So I'll also share it that way as well. So that's why I'm separating them out into modules. So you should have access to them later on. Let's talk about event-driven solutions with Lambda. Let me share my screen first. Wow, there we go. Bear with me one moment here. Okay. Okay, so developing event-driven solutions with Lambda. As you know, Lambda is serverless computing. So let's talk about what that is. Let's talk about an introduction to Lambda, how Lambda works, a couple of use cases, some key concepts, best practices, and then of course the core scenario, and then we'll do a little wrap up, which is our knowledge check. So what is serverless? Well, we talked about this before, where traditional application hosting typically relies on virtual machines. You put an app on there. You can't necessarily co-locate a bunch of apps on that virtual machine. And if you go up a level, you can run containers on top of virtual machines. And then all of that basically still requires you to manage an operating system. But with containers, at least, there's more abstraction and portability. So you get a lot of benefits with containers. Containers, at least in managed Kubernetes, or the ECS, the container service, can also go to what's known as serverless. Now, true application serverless just has you uploading code. You don't manage any servers. You don't even worry about that. If you're doing container serverless, that means you're still delivering containers and you're still running in a containerized environment, but you don't have to manage the boxes. This is application serverless, which means it's kind of like the original serverless, true serverless. And in this question, in this space, all you do is build and deploy your apps, and you monitor and maintain your applications. Everything else, scaling, installing the application runtime platform, updating the operating system, provisioning the virtual machine, none of that happens on our end. Serverless just means on a managed provider that somebody else is doing it. Now, there have been statements like you can do serverless yourself if you want to. And the truth of the matter is that while you can do serverless yourself, if you're managing your own hardware boundaries, it's going to be a different experience. Because with a hyperscale provider like AWS, they can invest millions and millions of dollars in hardware every month if they had to. And so they can stay ahead of whatever your capacity needs are because all the other customers are also needing capacity. So it's a little different when you run it in-house. It's not the same. But there are serverless frameworks for running in-house, just to be clear about that. So the concept goes beyond just AWS. So the benefits of serverless is that you're not managing servers. It scales with usage. In other words, you just call an instance of the function in question and it just goes, right? And then availability and fault tolerance are kind of built into the whole equation. And you don't really pay for idle instances. And Gerald, I can't explain it containers right now because that's a whole different section. But so I'll have to come back to that. But containers, that's a little bit of an involved explanation. But basically think of containers as process isolation, right? So we'll come back to it, but I can't do it right now. I don't know if there's a containerized section inside the developing class. There used to be, but it looks like it was removed. So now I'm kind of a little questioning about the whole thing. But I do have a short presentation on containers that I will give actually based on AWS material. Now with serverless, since you're just giving code, it's basically anything where it can either be strung together into 15-minute execution chunks or basically just any function, I mean, it can be anything in where there's like this kind of like customer kind of system interaction where it's like event, output, event, output, event, output. I mean, it can range from everything from automation to chatbots to data processing. It's not that complex actually. Now, if you need a 24/7 consistently running application that requires like constant scale and hit and interaction, that still might be a use case for Lambda, but you're probably going to be looking at either a virtual machine or containerized platform because those systems will run 24/7 continuously, you don't stop and start those. These are purely function and event driven. They have a start time and a stop time. Obviously 15 minutes is the cap, whereas you're not going to run into 15-minute caps with containers or virtual machines. So now serverless is a lot more than just Lambda. Like, for example, they'll tout AWS Fargate has a product. That's dumb, just so you know. Fargate doesn't exist outside of other products. So like ECS and EKS use Fargate. So I don't know why they tout it as a separate product. It's not. It's part of ECS and EKS. So those products have a serverless version. That makes a lot of sense, but those are container services. One thing that makes it even more confusing, Lambda will accept Docker containers as a packaging format for your applications. Just know that it doesn't really run it like Kubernetes or Docker, like Docker Swarm would, as an example. Now, that's where the app's going to live. Other functions, like if you want metering and caching, that's API gateway. If you want to be able to run a GraphQL database, like front ends for your data, AppSync will do that along with other synchronization pieces. Excuse me. Then you've got the simple storage service and databases, which we already talked about. SNS and SQS, which are used for messaging, which we haven't really dived into just yet. And then, of course, there's step functions, and that's probably the most important out of all of these, is that step functions will orchestrate Lambda functions. So if you're looking for a function orchestrator, kind of the way that Kubernetes is a container orchestrator, step functions will do that. It's basically a state machine that will allow you to document a workflow from end to end and just walk somebody, like, you know, a customer or a service through the workflow. It's pretty nice. Now, here's an example of a really interesting serverless architecture. So you got users at the top, and you got basic content delivery, which is coming either from CloudFront through S3, maybe as like a database backend. And there's probably some dynamic interaction on the website between the API gateway and Lambda against the data storage pieces. Now, the user is going to authenticate against Cognito, which both has a user and an identity pool and allows you to verify, authenticate, and authorize the user to get access to the other pieces. So think of Cognito as the user data store for the web application or the mobile application in question. So SNS and SQS, which you'll see on opposite sides in a diagonal there, the one's a notification system, which is what SNS is. And the simple queuing services job is to basically queue messages and let them be picked up for processing. So it guarantees at least once processing. DynamoDB, you know, is a database. S3 is the storage system, an external storage system. You can host HTML files and JPEGs and whatever there, right? CloudFront, by the way, is a content delivery network. Its job is to provide a caching mechanism globally all over the world for a single origin. In this case, the source or origin is S3. And so you can actually use CloudFront to take a single website and make it global, especially if most of the content is static. If most of the content is dynamic, CloudFront can help, but it won't be as good. So that's like a traditional, fairly standard serverless architecture. You could probably find 24 tutorials on how to do this inside of AWS if you search for it in Google in like 5 seconds. So Lambda has been around since at least 2014. So this is not a new service. It's been around for a while. For some reason, it didn't gain traction back then. People just weren't ready for event-driven architectures. Now you're seeing a bigger push for this. So then how does Lambda fit into this? Okay, so Lambda runs, since it's an event-driven architecture, it can be a time trigger or it can be an event trigger, or you can manually do it. You could push a button if you wanted to. But there's an event source, and what it does is it invokes the Lambda function. Or, by the way, just so you know, Lambda could watch an event source and it could respond. Like it could say, I'm watching the DynamoDB table. Someone put an update in there. Let me send a notification, right? Lambda, by the way, can talk to anything that code can talk to. There's a couple of restrictions, like it won't let you send email off of port 25. I know, but you know, spammers go crazy with this whole thing, right? I just got killed with a bunch of spam, by the way. So I thought I was laughing. Like, man, that's a lot of spam, just a short amount of time. Other things to note is that the function code, move that out of the way. Function code gets uploaded into Lambda, and it can be in a zip file, it can be an S3 bucket, it could be a Docker container. And the language, there are only certain runtimes for Lambda out of the box, but you can also create your own custom runtime. So, if everything's packaged in there, you can make it work. That's how it works. It gets triggered, or you trigger it, or it's a time-based trigger, executes your code, runs for 15 minutes, goes to town, right? So the code must be pretty stateless. There's no affinity for any underlying compute infrastructure, like local file access, child processes. They're not going to extend beyond the lifetime of that request. If you want to store persistent state for your Lambda function, there are tips and tricks at a low level to do that. But just also be aware that S3, DynamoDB, or any other internet-based storage service is going to be required. So, and Lambda functions can include libraries, by the way, including native libraries. Now, you bring your own code. You can do synchronous or asynchronous invocation. So like however you want to do that. Integrates with other services. I want to say it now goes, it's like power value from 128 megs to 3 gigs. I want to say it goes to higher than that now. Let's go take a look, actually. Yeah, about to say, it goes to 10 gigs now. So, yeah, that was like 2 years ago. Yeah. Huh. Anyway, so Lambda now supports 10 gigs of memory and up to 6 virtual cores for Lambda functions. This says as of 2020. So just so you know, you can go between 128 and 10 gigs of memory. So yeah, I was like, oh, that doesn't even look remotely right. So 128 megs is like your minimum starting point. Just so you know, as you stair step up your memory, like you go from 128 to 256 or whatever, your compute power goes up, but you can't choose them independently. They're in lockstep. So if you want more CPU, but you don't need as much memory, you still have to choose the high memory option because CPU and memory are kind of in lockstep with each other. Now, there are permissions that you give Lambda it's usually called, it's like run role or execution role. And there's permissions you give to other services to invoke that Lambda function called the invocation role. So you have fine-grained controls. You can, by the way, attach a network card to your Lambda function and stick it inside of your network, inside of a VPC, inside of AWS. Why would you do that? Security reasons, closer proximity to whatever data source it's pulling from, that kind of thing. Again, you can edit code inline. There's tons of editor plugins that will allow you to pop these things into Lambda. Obviously, Cloud9 works great. That was the IDE that we looked at earlier. Other than that, it's all pretty standard. You got metrics. You can use X-Ray. X-Ray is enabled by default when you enable tracing. Everything is automatically logged to CloudWatch logs. So when you print something to standard terminal inside of code, it just automatically goes to CloudWatch logs. So what can be a trigger? Yeah, a lot of stuff. You can actually get an S3 bucket to trigger a Lambda function. You could get Cognito if someone logs in. You could get CloudFormation. I mean, especially S3 and CloudWatch events in particular. CloudWatch events will track the state of pretty much anything going on inside of AWS. AWS config is the same way. Where is that at? I don't see it listed there, but config will also do it. There's a lot of ways to trigger a Lambda functions to say go, right? So here's some key concepts. First of all, there's the handler function, which is the actual, like, when the Lambda function's invoked, code execution begins at what's called the handler. The handler, by the way, is like a specific code method. Doesn't matter if it's Java or C# or it's a function if you're using Node or Python that you've included in your package. You're going to specify the handler when you create a Lambda function. So each, by the way, language has its own requirements for how a function handler can be defined and referenced within the package. So you kind of need to look at your documentation for Lambda to find out how to do that within your respective code. Now, what happens is that there's an event object that's used to pass in event data to the handler. The event object usually comes from the service that invokes it. So if S3 invokes Lambda, it's going to create the event object and it's going to pop its contents in there, including like things like what file was the trigger, or what change, was it a new file that was uploaded, right? So API Gateway, for example, will send in related details around HTTPS requests. Kinesis will send in information about real-time streams, right? So it's going to include details about what trigger was used to invoke the Lambda function. Ow, sorry. You're also provided, by the way, a context object. Now, the context object allows your function code to talk to the Lambda execution environment. You can do things like, what's the log stream name? What's the timeout in milliseconds before our function times out? Because remember, 900 seconds, right? 15 minutes. Every runtime, by the way, has the ability to stream like log statements, right? So the context object basically contains all the information about the execution environment that Lambda is running in. The event object is what triggered the environment, the Lambda function to run. Here's an example of the handler event and context for Python. Function called myHandler. That's funny. Basically, it's returning a message containing data from the event it received as input. So it's calling the event object and pulling out the information from the event object. Here's Java. Context object request handler. Okay, interesting. So the first handler parameter is the input to the handler, myHandler. And then which can be event data, by the way, it could be whatever, right? Or custom input you provide, or any object data. So it's going to return the string, the value of my count. And then here's C#. Output is of type stream. Okay. You'll see this also in your solutions code for the lab. So here's how it works. So if there was an event source that triggered, it's a push model. If Lambda is watching something and looking for changes, that's a poll model, meaning it's polling basically. If it's direct invocation, this basically means that something has called Lambda synchronously, and it is basically waiting for a response. A lot of the other times, the event-driven ones, like event source and AWS Lambda, the push and pull models, are pretty much considered, like event-based invocations. So you can deploy, obviously, from any IDE that has integrations. You can use any of the three ways. You can use an SDK, you can use the CLI, you can use the management console to upload it. Now, when you develop and deploy these packages, you can use a zip archive. You can't actually use a jar if you're using Java. You can't obviously use a zip file or a DLL if you're using .NET, right? So again, you've got options. You can basically install libraries using your standard method. So, if it's like Node or Python using pip, Node using npm, Ruby using gems, right? You can use Maven or Eclipse IDE plugins if you want to install libraries, or you can use NuGet or Visual Studio if you're using .NET. Obviously, everything has to be at a different level depending on what kind of code it is, right? So if it's like Node, Ruby, or Python, it's all going to be at the root level. If it's Java, it's all got to be compiled. And of course, the jar files are going to have to be in the live directory. And then all the DLLs for running for .NET Core, they all have to be basically at the root level as well. So there's a lot of deviations, variations. Like You can, modify for .NET. I know you can modify the runtime config JSON in order to like include class paths in as part of the build process. Here's another develop deploy example, is that you create a Lambda handler in your code, create the Lambda function, right? Associate a role with the function in question, upload the code, and then invoke it, and it'll use the role to run while invoking the code, and then go check it out on CloudWatch to see exactly what it's doing, right? How was it invoked? Were there any logging statements that were released? That kind of thing. Now, interesting. You do have synchronous and asynchronous calls, right? So remember, synchronous means it's going to wait for a response. Yeah, Antonio, you can programmatically create anything. So yeah, there's no restrictions on what you can create programmatically. Synchronous, is going to basically say, I'm going to request something, I'm going to wait for a response. Asynchronous is like a trigger to response. You just go, you can send me a separate notification. Stream-based is where it's just continually eating changes. So that's not really synchronous, but it is constantly interacting and listening and taking in multiple parts of data. So again, it just triggers and eats changes, triggers and eats changes. So in this kind of push event model, right? Events are kind of pushed to Lambda, right? Which triggers Lambda to go to town. And the poll event model, what happens is that Lambda is actually polling. Lambda is actually watching the services, and it's going to invoke when it sees a change, right? I would tell you that push is probably still like the most popular. Something hits the service calls Lambda, but not every service actually can talk to Lambda, right? So, just depends. And then direct invocation is just, again, mainly for custom applications who just want to invoke and then kind of wait for a response. So. Now, execution permissions, as I mentioned before, is basically, and there's execution permissions, which says, what can Lambda do? Like if Lambda wants to execute against other things, what kind of permissions are we going to give it? And then there's invocation permissions, which says, who can tell Lambda to go? Who can tell that Lambda can go forward? Event object, is that based on the service? Oh, Austin, I didn't even answer your question. I'm sorry. How is the data on the event object specified? So data on the event object, did I just zip past that? Hold on. Data on the event object is controlled by the service that invokes it. So like if S3 invokes it, it's going to send a different set of events. Like there's going to be everything that service could send, it's going to send in the event object. You're not necessarily going to read everything in the event object. So you have to look at what the service is going to send. Like you could examine the object to see exactly what it sends, right? If you want to, you could also read the documentation. So just know that it's dependent on the service. And then what you configured for the trigger. So like if I configure S3 to only send to trigger if a file is changed, it'll send different information than if it's like if a file is new, right? A new file is put there. Because if a file is changed, it'll probably tell me what file has changed. And if it can tell me what change it is, it's going to post it. With a new file, it's just going to tell me that a new file was posted. It's not going to tell me anything else. Sorry. Yeah, I missed it. So if it was SNS, by the way, what message was posted to SNS, including contents type? Was it an email? Was it an SMS push, like a text? Was it a web post? That's what the event object will send. So it's going to post everything it can, but you're only going to grab the things that you want. So, and it's not going to be a lot of data, to be frank. Sorry to go back like that. Just want to make sure. Okay, so from a permission standpoint, you have what can Lambda do and who can tell Lambda to do something, right? So just know that you have to assign both sets of permissions. And here's an example. So yeah. So interesting. So what's going to happen here is that you have to create an execution role through IAM. And by the way, you can do that programmatically, right? You want to create the role, grant Lambda permissions to assume the role, which is defined into the role itself. And then you have to attach an access policy to the role that grants like the needed permissions. So I know this sounds strange, but roles have the like a standard access policy, like a permissions policy, like we do with any identity base. So users, groups, and roles all have basically what they call an access policy. But in addition, like there's a trust policy for roles that says who can assume the role. So your trust policy has to basically say that your Lambda service can assume the role in question. So, and what that basically means is that you need to basically grant the whoever's creating the role in question has to have the pass role function to be able to create this trust relationship, right? This trust relationship, this trust policy says these are the services that can assume this role. And it's different from the access policy that the role has, because the role grants a certain set of permissions, right? No, Jacob, this is all within IAM. This is all role-based. So this is all identity-based. It's not resource-based. Oops. Notice, by the way, oh, what did you do there? Hold on. Oh, this is getting fun. Good job. Hold on. Nice. Notice that this is all basically done in IAM. Notice that here they're basically saying that Lambda as a service can access and assume this role. Have to be careful with that. You might need to specify a specific Lambda function, but this is basically saying that Lambda can assume the function in question. Resource policies do have principals and SIDs. This is a trust policy. This is a third type. This is a different policy from identity and resource-based policies. This is something that exists only for roles as far as like who has the ability to assume the role. So if we were looking at IAM for this, assuming that I am logged in, which I am not. Nice. Hold on one second. Let's go take a look at this. MFA for the win. So let's go take a look at IAM, and let's go take a look at like a role, for example. So if we're looking at a role, let's say it's the M Forrester role that you saw me switch to a couple days ago. There's actually a section in here, if you look, that says the trust relationship, which is also in a sense the trust policy, right? The trust relationship here, right? And you can show the policy document if you want to see it. Here's what it looks like. Notice it says that basically anybody, and I actually added this in recently, is that if I was the root user, I could assume this role, right? But it basically means that anybody who basically is part of this account can assume this role in question. So this is a part of the policy definition inside of a role. So you have to say who can access it. So trust relationships can be very specific. You could come in here and say, look, I only want this specific Lambda function or this specific person or this specific EC2 instance to be able to adopt this role. Be careful with that, because obviously if the EC2 instance floats around, that could be a problem. But you can say, look, these are the only entities. You could set conditions in there to say also anybody with this tag can assume the role, right? So cool. Just want to make sure that was clear, Jacob. So you're going to attach a trust policy, which is part of the role. You're going to attach an access policy, which is part of the role, right? And that gets attached basically to like the Lambda function. It has an execution role. So this gives the ability to basically run as this role. Now, invocation permissions are different, because what needs to happen is that, oddly enough, if an event is going to trigger Lambda, you have to give the event service permissions to trigger Lambda. If you just want Lambda to pull a service, That's still execution permissions because you're telling Lambda what permissions it has. Invocation permissions are permissions for services that are not Lambda, because Lambda is not the trigger. Hold on one second. Okay, so again, in the push model, what's going to end up happening is that with the push model, you got to make sure the service has permissions to touch Lambda. With the pull model, you have to make sure that Lambda has permissions to touch the service. It's got to be able to pull it, right? Here's some other push examples with invocation permissions. This is going to allow Lambda, by the way. So S3, by the way, here, it looks like S3 is being granted permissions to basically invoke, right? If the event source is the example bucket, because it's the example bucket limit, right? And B, it looks like what's happening is API gateway is granting principal permission for the Lambda invoke action, like provided that the request is coming from the API gateway. Now, to be clear, statement ID, the service, source ARN. Obviously, these are being attached, by the way, to the resources, right? And they've got principals, so they look like resource policies to me. Now, I'll be frank, I don't know that I've ever done that with API gateway. I didn't know that API gateway could support resource policies. That's not one of the 4 services that I'm aware of. But I got to tell you, that gets a little fuzzy because you can assign permissions and roles to a lot of AWS services, but you can't explicitly assign resource policies in a lot of cases. So again, if it's able to invoke another service, there's already some kind of resource policy in place. But typically in terms of you being able to edit and attach a policy, there's really only 4 services. This would actually be done programmatically, right? And invoke a Lambda function. Now, with function execution, remember you're limited to 900 seconds, right? The default timeout is 3, but obviously you can bump it up if you want to. Duration, by the way, is calculated from the time your code begins, rounded up to the nearest 100 milliseconds. That's actually not correct. It actually, well, it'll bill to the millisecond now, if I remember correctly, right? So I think that's been updated recently. It'll bill to the nearest millisecond if I think that's been shifted. So I don't think it rounds up to the nearest 100 millisecond anymore. Lambda can be run on a regular schedule. So for example, you could get like a cron level expression if you wanted to. You could run it at every certain amount of time. Scheduling, unfortunately, seems to be only available as a scheduled event, as an event source. I think that only works through the console. You can, by the way, get CloudWatch events, which you can do programmatically to trigger a Lambda function, which you can also do it based on time. So just know that you're not only limited there. There are some restrictions. You can't take any inbound network connections. Only TCP/IP is supported, so no UDP. And of course, you know, debugging is somewhat limited. They don't want you to completely trace out everything that's going on in their back end. And of course, you can't send over SMTP. So it's there as an anti-spam measure. Other things to note is that you can version and alias your Lambda functions. This is kind of cool because aliases are like immutable pointers to different versions of your product, of your Lambda releases, right? So you can change the function code and settings only on the unpublished version of a function, but once you've published it, right, you basically end up with different versions of your same Lambda function. That also means, by the way, that there are aliases like $latest. You could put like dev or beta or prod, right? And you can alias these names to different versions of your product. So for example, let's say latest is dev right now, and you publish it out, and then you publish it to beta, but then maybe prod is linking back, right? You can define prod as an alias to like version 1, for example, after it passes like all the beta testing, you know? So what you can do is you can keep prod on the latest stable version. You can put beta on the one that's being like beta tested, and you could put dev maybe on the one that's like the one that developers are using, and maybe QA is the one that's about to be released into beta, right? So you can actually add these dev, latest, beta, and prod like keywords in that allows you to alias to different versions of your code. So very useful. You can also do some traffic shifting with this if you combine this with API Gateway, which is very useful. Now, you can configure your Lambda function to pull in like additional like code if you want to, and content as layers. Think of a layer as a zip archive that contains like libraries, you know, other dependencies, and with layers, you can use libraries in your function without necessarily including them in your deployment package. In other words, layers will let you keep your actual change deployment package small, but then other layers could contain like the base runtimes, the dependency libraries that you need that aren't changing. Maybe the deployment code is changing, but the dependencies are not. So, you know, the deployment package, you know, usually it's considered needs to be like smaller than like 3 megabytes. But a function can use up to 5 layers above that at a time. And like the total unzipped size, like for example, cannot exceed 250 megabytes for your package. That also encourages you, by the way, to keep your functions tiny, right? And so layers are abstracted in what's known locally inside the like Lambda kind of container, if you will, has a /op directory in the execution environment. And so each runtime is going to look for libraries in a different location under op depending on the particular language. So you want to structure your layers so that any dependencies or runtimes or layers, you know, can access things in op without having to do additional configuration. So the serverless application model, also known as SAM, will help you kind of navigate those pieces. But this is a way of you creating independent deployment packages that don't require you to re-release the dependency layers every single time. Remember, 250 megabytes is the cap size, if I remember correctly, for everything unzipped. So this is going to be relatively tiny. It's not going to be a 2 gigabyte package. All right, so let's talk about a few use cases. So scaling events, by the way, can trigger Lambda functions, right? So this can call, you know, a bunch of services via APIs. You know, this could be like you could scale your EC2 instances or Docker instances or add more caching. You could scale databases. You could look for streaming performance data. Really what happens is that Lambda basically just becomes this kind of like lingua franca for calling anything that you want to trigger based on either other event services or any one-offs you want to do. So you can create like self-healing infrastructure. You could have it so that if like you get a security finding against your security groups, Lambda could be triggered to lock down all the security groups, right? If someone launches an EC2 instance using an unapproved AMI, this would shut it down, right? If you didn't already have a policy that prevented that from happening. So it's really is like an enabler for so many other things. Here's another example. Here, by the way, if there's a stream of items changes, by the way, you can basically trigger a Lambda function to like get records from the DynamoDB stream and either order them or respond to them or notify against them or, you know, a bunch of other things. And then best practices is basically, you know, make sure the Lambda handler is separate from the core logic. That way you can make a more like testable function. Make sure you use operation like, you know, execution context reuse. So like externalize any configuration or dependencies, right? make sure that any like externalized configuration or dependencies are stored and kind of referenced locally, like either put them in layers or do something like after initial execution. You want to kind of limit the reinitialization of variables and objects on every invocation. In other words, if you execute your Lambda function and the first thing it does is it downloads a bunch of dependencies, don't do that. Like, make sure the dependencies are folded into the layer, like the layering. Don't make it externalize those calls, because that means every time it runs, it's going to download those external dependencies. Just put them as part of either the layering or the deployment package if it's small enough. If you're writing, for example, to an S3 bucket, hardcode the name of the bucket you're writing to as an environment variable if you need to, or put it into some kind of like external database or configuration file. Preferably, though, you would keep it locally. Try to keep the deployment package as small as possible. Make sure you're minimizing your dependencies. Like, try to choose frameworks that load really quickly when the executive context is started up, right? Like simple like Java, like dependency injection frameworks like Dagger or Geis would be good. And try not to use recursive code. If you use recursive code, by the way, in your Lambda functions, where it calls itself when some arbitrary criteria is met, that could lead to a huge volume of unintended recursive Lambda calls. And the next thing you know, you're at 1,000 executions a second, and you're like, what's going on? By the way, if that happens, just set the concurrent execution limit to 0 to throttle all invocations down, and then update the code. Okay, just so you know. Obviously, you want to performance test and see what the sweet spot is, because you might find the sweet spot between memory and Lambda. You want to load test it. Understand the limits. There's like interesting limits in here, like like the max of memory is 10 gigs, right? But you also have a temp space, which is about half a gig in size. Payloads for like request response and synchronous invocation payloads can only be 6 megs. There's lots of weird stuff like that. The total size of all the environment variables can only be like 4K, right? It's like weird stuff like that you got to pay attention to. You can point it to private repos. You just can't initiate inbound connections to Lambda, but it can download stuff from the internet. Obviously authentication is a problem. Yeah, it can go out and talk by default. No inbound connections, but Lambda can initiate outbound all day long. Just so you know, that's the way EC2 works too. If you launch in the default VPC, you can't get into the EC2 instance, but it can go out and grab stuff as it needs to. Make sure you know that if you want to find out what's going on with the Lambda function, you have to look in CloudWatch under metrics and or alarms. And if you're doing an asynchronous invocation, what do you do if the invocation fails? How do you get a notification? How do people find out what's going on, right? Okay. Now our scenario here is that let's say we're hosting a website. By the way, there was a company called A Cloud Guru that actually did this. They hosted their entire website on S3, and they used API gateway with Lambda functions to talk to the DynamoDB table for dynamic invocation, and they used Cognito for authentication. Amazon was really happy about that for a long time, because this is like 2015, 2016 when they were doing this, and so people were impressed they had orchestrated it this way. No servers for a website that was hit pretty heavily. So here we've got a list, create, update, search, and delete functions for our DynamoDB table. These are Lambda functions. They can be called, but we're missing something here as far as the invocation piece. It could be when they upload something to the website or to the MP3 bucket. But later on, you're going to see API gateway kind of thrown in here. So let's do a quick knowledge check. True or false? Lambda handles servers, capacity, and deployment needs for you. Is that true or false? It's true, right? It is going to handle all the servers, capacity, and deployment needs for you. It will not handle the actual deployment of code, but it's true. It's going to handle all the servers, all the capacity, everything underneath, right? It's going to ask you a few questions, but that's it. For the most part, if you want to run 10,000 invocations of your function, you have to, the only thing you'd have to do is raise the execution limits, because I think 1,000 is the default, but that's easy. Your AWS Lambda function needs invocation permissions to access other resources in your account. Is that true or false? Is it true, just to clarify this, is it true that it's called invocation permissions, or is it called something else? Yeah, so it's actually called execution permissions. Remember, execution permissions are what allow the system, Lambda in particular, to talk to other services. Invocation permissions are what you need to allow a service to talk to Lambda. So execution permissions allow Lambda to do things. Invocation permissions allow a service to do something to Lambda. The trust policy only comes into play when you are assigning execution permissions. But remember, execution permissions include an access policy and a trust policy. Both of those make up the execution permissions. So remember, the trust policy says this role that grants this access, Lambda is allowed to use it. That's what a trust policy is, and that's part of a role definition. And creating a Lambda function is only possible via the Lambda console. Is that true? Can you only make a Lambda function? Is that only possible using the console? I hope not. Now, scheduling one manually without using CloudWatch events, I think that's actually still true. I think you have to use the console for that. But otherwise, every other thing you can do using the command line. It's weird that the console is the only way you can actually directly schedule a Lambda function, like to run it based off time. But programmatically, you can just invoke CloudWatch events and have it invoke based on time a Lambda function. Okay, if you enable DynamoDB streams on a table, you can associate the stream ARN with the Lambda function that you write. Is that true or false? Can you have Lambda basically be associated with the stream that gets invoked when it gets updated? Yeah, no, you can actually. It's good. Cool. All right. Other questions? All right, here's what we're going to do. We're just going to take a very short break. Okay, so we're going to take 10 minutes because it's 1:55 right now. So come back at 2:05 and we are going to pick it up with API Gateway and then we're going to roll into a lab. Okay, so 10 minutes. I'll put up a little timer.